Welcome to Sacred Cow Shipyards, where no ship is safe from being taken down to its nuts and bolts. So a few episodes ago, I introduced y'all to the concept of an automatic bus transfer switch. That is to say, a literally very large switch on the wall, reminiscent of perhaps Frankenstein's laboratory, that can also be thrown automatically if the power from one side of the switch fails. And therefore it fails over to the side that still has power, and then the system that one or the other of those two power grids was, powering, keeps its power on. There's lots of power going on. You find these frequently in systems that have to stay, on, so you find them frequently on particularly U.S. Navy warships. I have no idea about other countries, but I feel certain they do something similar, if not absolutely identical, to what the U.S. Navy actually does. After all, stuff breaks. And if nothing else, these are warships, and they are going to get shot at, and power systems are going to go offline for any number of reasons you want to choose. It could be anything and everything from the diesel generator itself being taken out to the single wire powering that ABT suddenly being randomly sliced by some random piece of shrapnel randomly showing up in a random spot at a random time. Okay, so what happens if both sides of an ABT go down? Because that's never happened before, right? Or say, what happens if the power to a very important piece of equipment on the ship gets severed after the ABT? As in the automatic bus transfer switch was keeping the space that the equipment lived in powered. Say the ABT is perfectly intact, but the wire from the ABT to whatever switchboard to the piece of equipment you really, really need running right now was severed or damaged or in some way inoperable. What do you do? Well, the bad news is that most equipment on a warship is hardwired into said warship. It's not like your washers and drying machines at home where you just plug them into a special outlet and everything's happy and shiny. And speaking of, most of the significant equipment on at least USA and Navy warships use three-phase power, specifically at 440 volts if anyone actually cares. The short version of this, and I'm only going to do the short version because the status of power distribution and plugs and all the rest of that nonsense on your planet is absolutely nightmarish, and this is not that kind of channel, and my little circuit starts smoking when I start looking into the particular details. So we're just going to gloss past all of that and make this as universal as I possibly can, and I'll still probably miss an edge case. Most, if not all, of the countries on your planet, when you plug something into the wall, however you manage to accomplish that, use alternating current power at the wall. And most of them only use a single phase for most, commercial type devices. Your computers, your computer monitors, your televisions, your phone chargers, those kinds of things use single phase power. Now, the phase and the frequency and all that nonsense, much less the voltage, again, not going there. What is alternating current? Well, basically the direction the electrons are flowing alternates on a certain period, as opposed to direct current, where the electrons only go in one direction all the time. And this alternating current effect can be somewhat accurately represented by a sine wave on your mathematical charts. Now, why is it called single phase? Because in a single period of time, you only get one up and one down. That's called a cycle, and when combined with the amount of time it takes to perform a cycle, you get the concept of a hertz. Well, so what's three-phase? In the same amount of time, you have three ups and three downs. Obviously not stacked up against each other. They are 120 degrees out of phase with each other in that time period. And this is particularly useful because you can power certain heavy equipment much more easily using three-phase power. Also, it takes less copper or whatever other conductive material you're using to get the same amount of end power from point A to point B, as opposed to with three one-phase systems. And conveniently, if you set your systems up properly, if you want to step from three-phase to one-phase, you basically isolate one of the phase lines, one of the conduits that is carrying one of the phases, and pair it up with a neutral or ground wire, and suddenly you have a one-phase system. It's basically impossible to do the opposite, though, because you have to get all three phases in phase or perfectly out of phase, however you want to phrase it, and that requires some specialized equipment. You can't just pull a wire off and call it done, or wrap all three wires together and call it done in this particular case. Where am I going with all this? Well, the wires are kind of chonky, and the system is kind of complicated. In terms of wiring, think, for those of y'all, at least in the North American continent, your dryer wires and the big plug that you have to use to get those into the wall, at least for the electric dryers. I assume the natural gas-powered dryers have smaller plugs simply because they're drawing much less current, but I have no idea. I only do so much research about you weirdos. Regardless, big wires, big thick wires attached to big thick wire nuts inside of the equipment. And somewhere in this wire, it got snipped. So you'd have to isolate the breakage first and then splice that together, which doesn't seem terribly good idea to be doing in a combat-style environment. What do? Well, amusingly, despite me referencing it somewhat disdainingly just a few minutes ago, the fact of the matter is you use extension cords. And you use them with biscuits. No, I am not making this up. Look, okay, the situation is pretty simple. All you have to do is get 3 wires to a piece of equipment from an energized source. You don't have to use complicated things, and biscuits work just fine. Wait, I'm being handed a datapad by a minion. Wait, that's what you think biscuits are? And that's what they think biscuits are? What the fuck is wrong with your planet? Okay, apparently the term biscuit is a colloquialism that is shorthand for casualty power riser. Now what the hell's that? As mentioned previously, there are at least probably 2 primary power sources for each major compartment or equipment in a US Navy warship. Ergo, you could kind of abstract that notion to the generalized idea, and this is entirely false, but it'll work easier for the explanation, that there are 2 disjoint power grids on a US Navy warship. Again, this is wrong. There are actually more than 2, but for the sake of simplicity, let's just assume there are 2. One backs up the other. And then you have a patchwork monstrosity that backs up both. You see, basically every major quote-unquote source of power on a warship, whether it's a switchboard or a specific control panel, or just a random bulkhead, and we'll get to why that's just totally weird in just a second, has one of these casualty power rises either on it or connected to it and run somewhere else. So that's the first leg of our patchwork. But the power source only goes to the terminal. It's a disjoint system. Well, that's because around the terminals are wrapped extension cords. And no, I am not making this up. They are simply 3 thick wires bundled up together into a single cable. It's of a certain length, and the whole point of each individual casualty power riser is from that one, you can get to 2, 3, maybe even 4 other risers. Or as they're correctly called, biscuits! And from there, the next riser might simply be a built-in extension cord that goes to another bulkhead, or a piece of equipment, or some other thing that needs to be energized. And that's the marvelousness, the magic, if you will, of this particular concept of a system. The hard lines on USA and Navy warships, aside from allowing people to escape the Matrix, also can only power one thing at a time. You can't move them around. They're not designed for that. Whereas the casualty power system is specifically designed for you to route, well, casualty power to wherever it needs to go. Now, there are some catches. This is not intended to be a permanent solution, specifically because a lot of the routes that the extension cord has to take would go through doorways or watertight doors. And watertight doors specifically are, well, watertight, and in combat situations, you typically want to keep those closed, unless you really need something powered on the other side. And yes, just as a brief divergence, anything vertical on a ship is referred to as a door, whether it is watertight or not. Behold, a quick-acting watertight door. Quebec Alpha Whiskey Tango Delta. Hatches only go in floors or decks. They are horizontal. Something that most science fiction gets wrong and most authors get wrong. Free advice for you out there. So yeah, this is very much an emergency kind of use. In fact, if you want to keep a quick-acting watertight door open during combat situations, you have to get approval not only from Damage Control Central, not only from the bridge, but also from the captain himself, last I was told. For any kind of hookups that don't require quick-acting watertight doors, you still have to go through Damage Control Central, because they have to know all of the various routes that power is now taking through the ship, and all the various trip hazards and all the various other problems that could happen by having literal power cables laying on the literal deck. That's not normally where they go. They typically go under the deck, or in what's called the overhead, the ceiling. And this is the other problem. Due to, quote, safety, quote, regulations on your ships, personnel travel through areas where there are casualty power lines laid on the deck is strictly restricted to essential, and maybe not even that. Basically, humans aren't allowed in the areas where the casualty power lines are laid simply because of trip hazards. Y'all are clumsy as fuck. Also, as mentioned, there is in fact 440 volts of 3-phase power running through those cables on the floor, but they're perfectly insulated. The only problem is at the ends. And speaking of the ends, as I mentioned, every cable has 3 prongs, or 3 individual wires inside of it. 3 cables inside of the cable. Yo, dog, I heard you like cables, so I put cables in your cable so you can cable while you cable. Oh, that really gets awkward depending on which kind of cable you think I'm talking about. Oh boy. Anyways, and conveniently, each biscuit has 9 holes. Man, that came out wrong. Obviously 3 for each phase. And thankfully, the phases are labeled A, B, and C. Are the cables labeled A, B, and C? Well, no! But wait, there's more. Conveniently, the 3A terminals are colored black, the 3B terminals are colored white, and the 3C terminals are colored red. And in fact, the 3 individual cables coming out of the one big cable for the extension cord are likewise colored. Stick similar colored into similar colored at one end and do the same at the other end, and you're good to go. Okay, but wait a second, hold on. Surface ships are big metal cans, right? Right. Surface ships don't have a lot of windows in them aside from the bridge, right? Right. I mean, technically the captain's stateroom probably has a porthole or two, and maybe the XO stateroom, but beyond that, there are basically no windows on warships. So what happens if the power goes out? Good question. I mean, at that point, you can't tell the color of the cables, right? Or say if it's a smoke-filled environment. Say there's a fire, it's a Sooties fire, it's a Class Bravo fire, and you can't see your hands in front of your face, and if you hold them right up to your face, how do you determine which cable to put where? Well, conveniently, the extension cords have a solution, and so do the terminals themselves. On the extension cords, on the A phase, the black phase, at the end of the cable, right before it gets to the spicy copper part, there's a ridge in the insulation, just one. On the B phase, the white phase, there are 2 ridges, and on the C phase, the red phase, there are 3 ridges. And coincidentally, on the biscuits, directly out from the middle terminal of the A phase, there is 1 bump in the plastic. And on the B phase, there are 2 bumps. And on the C phase, there are 3 bumps. And these are bumps and ridges big enough that you can feel them through firefighting gloves, by design, by intent. Now, how you find the riser terminal in the middle of a blackout space, I have no idea, but at least someone thought far enough ahead that, hey, we can do this literally by touch. And speaking of touch, if any of y'all are electricians in the audience, you've probably been staring at the ends of these extension cords and wondering, okay, fine, you shove this copper-capped thing into this hole. It ain't gonna stay, is it? The answer is no. The biscuits, in fact, do not have the spring-loaded grabby bits inside of them that some of your wall outlets in some of your countries, in fact, do have. And again, I'm not going to get into that nightmare. So instead, the way things work in this particular universe is you attach the cables to terminals, casualty power terminals, starting from the load end, and then you use the convenient, cute little wrenches that are provided at every single biscuit terminal location, and you set screw them into place. And then you work your way up the chain to finally a power source, and then someone with appropriate personal protective equipment does the final screw into place where they lock the load end into the wire and make sure the wire doesn't fall out. Technically, you're supposed to have all 3 wires in before you do the locking, and technically the wrenches are insulated, and the person doing the wrenching should be wearing insulated gloves, and this, that, and the other. It's still a little sketch, but you know, warships. To be bluntly honest, any warship that hasn't done anything sketch has never been in combat. Now, there are some warships who haven't been in combat who have done some pretty sketch shit, but that's a different conversation. So yeah, there you have it. That is in fact how USA and Navy warships actually manage power distribution when things go entirely wrong. When you literally have to string up an extension cord from point A to point B, because that is the only choice available to you. But the funny thing is, the ship is actually built with built-in semi-extension cords already in the ship. So you just have to get extension cord from power source to wall terminal, and that'll get it over there. And then you can do another extension cord from wall terminal to wall terminal, and that'll get it over there. And then finally you can do another terminal to actual equipment that needs to be powered, and behold, we have power. Now, technically, as I remember what I've been told, which, again, I never trust you humies to begin with, and certainly not in the situations where I am extracting information from them, but anyways, you're not supposed to string casualty power that far, but still, it provides a bypass, a solution, a method of getting back into the fight. Which, after all, As the inimitable Captain John Paul Jones, the father of the USA and Navy, once said, "I wish to have no connection with any ship that does not sail fast, for I intend to go into harm's way." Amusingly, as yet another digression, I would note that John Paul Jones himself was the only American warship commander, nominally, he was a captain in the Continental Navy after all, to lead any kind of attack on the British soil, the once great British soil. Yes, in fact, John Paul Jones led a landing action on the beautiful town of Whitehaven. Amusingly, it's where he started his naval career, and he had a lot of not nice things to say about the people who helped him on his naval career there in Whitehaven. And he did a no-joke raid and, did some stuff. It was notable, at least. Well, it was mostly notable because his crew got too interested in getting drunk as opposed to lighting the town on fire. So, trade-offs. At least they managed to spike the guns so they didn't get shot in the butt as they evacuated the area. But still, it's the only USAian assault on the once great British Empire during their War for Independence. Can't count for nothing, right? In fact, it didn't count for nothing so much that this raid occurred on April 17th, 1778. And it took until 1999 for the city of Whitehaven to get over the fact that they were drunk dry by some USAian sailors and possibly Marines who were sent there to burn the town to the ground and instead got distracted by getting drunk. You'd think they'd appreciate that more. Anyways, in your year 1999, the city of Whitehaven gave a posthumous pardon to John Paul Jones, and in fact gave the U.S. Navy the freedom of the port, whatever that might mean. Ironically, Mr. John Paul Jones's corpse, when he finally died, a Frenchman by the name of Pierre-François Simereau donated a prince's sum to ensure that his body was mummified and preserved in alcohol until the USAians could recover him, and recover him they finally did. And now he rests in state in the town of Annapolis in the sub-province of Maryland in the super-province of the United States, if you ever want to go visit him and pay him your respects. I wonder what he'd think of what his navy has become. But that's definitely a topic for a different channel. And that's all from Sacred Cow Shipyards. Please be advised that any ship left on the docks for more than 24 hours will be compressed to a cube at the owner's expense. Have a nice day.